Hello friends, this video Limits and Derivatives Part 14 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 13. What is derivative? Derivative is used when you want to find the rate of change of a function with respect to the input bar. Let me repeat. Derivative is used when you want to find rate of change of function with respect to WRT input value. So I'll give an example to explain this. The handwriting is bad, so we can ignore this. So let's have this car. This car is traveling, right? This car is traveling from point A to point B. And I want to find the speed of this car. So if we assume that this point is, let's suppose 10 meter, this is 20 meter from point A, this is 30 meter, this is 40 meter, and this is 50 meter. So distance between point A and point B is 50 meter. This is the starting, so I'll make it 0 meter. This is the distance, and let's suppose this was time is equal to 0, time is equal to 1, 2, 3, 4, 5 seconds. This is the value of time, let's suppose. Now if you see, I want to find the speed of car. So this equation I can say that the distance, I can if I say this is the distance, this is the time, so I can say that distance time graph, I can say that this is the function. I have a function where I give time as an input, right? And what I get is distance. Correct? This is the function. I give time as in value of distance. This is the function. For example, so if I give f of 0 at t is equal to 0, this value was 0. F t is equal to 1, f of 1, this is the function which takes time as input, gives a distance as output. Distance was 10, correct? At t is equal to 2, when I say distance was 2, the time was 2, the distance is 20. Similarly, f t is equal to 3, the distance was 30. At t is equal to 4, the distance was 40. And at t is equal to 5, the distance was. So assuming this is the function I have where I just give the input as time and I get the distance covered. This is the function I have. This is of this form, y is equal to fx. Now if I want to find the rate of change of distance with respect to time, so here if you see the rate of change of value, here I want to find the rate of change of value of function. The value of function is distance. So I want to find rate of change of distance with respect to WRT time. Correct? And that is nothing but our speed, rate of change of distance with respect to time. So to find this, we can use derivative, right? To find this rate of change of distance with respect to time, because here I have a function where I have saying that distance is nothing but function of time. So you give any time value, it will tell you how much distance this car has covered. So if you can create such function, and then if you want to find the rate of change of function with respect to time, then you can find using derivative. So in any equation y is equal to fx, if you want to find the rate of change of y, that is dy by dx, we can use derivative to find this. So we'll have the formula to find this, we'll explain, but just understand the concept of derivation. Derivation is used to find the rate of change of value of function x with respect to input parameter. So here we have a function that is function of time which gives a distance as the output. If I want to find the rate of change of distance, that is d of distance with respect to time, that is d of time, we can use derivative. I'll explain the concept, but this is the basic idea of derivative. We want to find the rate of change of a function value with respect to the input parameter. For example, for y is equal to fx, if you want to find the rate of change of y, that is a function value, with respect to x, that is the input parameter. So rate of change of function value with respect to the input parameter, we use derivative. So we have this function f of x. So we have this function f of x. So we can say that for this function we want to find the value of d of, let's suppose this value came f of y is equal to fx. Example, we have this y is equal to fx. D of y with respect to, let's suppose h. H is the time frame. I mean h is the value. So this we can find using derivative, and that will be, and this we want to find at a point a. For example, a car is moving, right? So if I want to say dy by dt is the speed of the car, but speed of the car is not same always. At point 0, speed of the car may be 2 meter per second. At point 5, the speed of the car may be 10 meter per second. At point 10, the speed of the car may be 60 meter per second. The speed, that is the rate of change of distance with respect to time, also changes with the point we are referring. So here at point A, for example, at point A, if you want to find the rate of change of this function with respect to h, then we can use this formula. F of a plus h minus f of a by h is nothing but the rate of change of this function at a with respect to h. Let me explain this. Let's suppose this is a function. This is the function. This is the function we have. This is a function, I'll say fx. And this is the value of, this is a. Now at this point of time, I want to find the rate of change of this function with respect to this value. So let's suppose this is a dash, right? So, or let's suppose I will take this value a dash here to make things better. A dash. This is a dash. So if you see, this value is a dash. Now this value f of a is nothing but this value. Let's suppose this is y, and f of a dash, this is f of a dash, this is a dash actually. So this is nothing but this value. We'll take this guy, y dash, let's suppose, correct? So we can say that y is nothing but f of a here in this equation. Y is nothing but f of a, and y dash is nothing but f of a dash. This is a dash. So if you see, there is a triangle here, right? So you want to find the rate of change of this value, that is y minus, this is y, this is y dash, right? With respect to this. So if you see, this value change is nothing but f of a minus, or f of a dash minus f of a by this value, a dash minus a. This will give you rate of change of this function, correct? This will give you rate of change of this function with respect to this time. But now I want to find exactly at this point. So instead of a dash, I can say that a dash is nothing but a plus h by, see, first make things clear here. What I'm trying to say, I'm trying to find the rate of change of this function with respect to this value. So this value will come out to be f of a dash minus f of a by a minus a. That is how it is. Rate of change of this is a dash minus a, and rate of change of this value is y dash minus y, and that is nothing but f of a dash minus f of a. Now since this duration is long, I want to find exactly at this point. So I can, instead of taking a dash here, I'll take a dash exactly here. Exactly, I'll take a dash, and I can say that a dash is nothing but a plus h, where h is almost 10 to 0. Almost 10 to 0. So that is, this a dash is almost near to this. So instead of a dash, I can say a plus h. This will become f of a plus h minus f of a by a dash. I can say a plus h minus a. This cancel, and this is the where h is tending to 0 now, limit. This is nothing but f of a plus h minus f of a by h, where h tends to, and this is the derivative. This is exactly the same formula we have used here. You have got what I'm trying to say? We have this function f of a is y and f of a dash is y dash. So if you see, from here to here, the function changed from y to y. Change in y axis was, you can say, y dash minus y. That was the change in y axis. change in x-axis was nothing but a dash minus a. That is a dash minus. This was the change in y with respect to x, right? Now, and that's what the derivative is all about. Change of this function dy by dx. If this is the x coordinate, I say, and this is the y coordinate. So dy by dx is the derivative as per the definition goes. Change in y with respect to x is derivative of y with respect to x. So here dy is nothing but y dash minus y, and dx is nothing but a dash minus a. Y dash we can say is nothing but f of a dash, and y is f of a. Now since we wanted to find this value exactly at this point, so instead of taking a dash far away from a, we'll take a dash very near to a. That is, a dash is a plus h. So we can say a dash is a plus h. So we can say f of a dash is f of a plus h, where h tends to 0, and a dash we can say a plus h, and we got this equation. So we can see that the limit of, or you can say f dash a is nothing but f of a plus h minus f of a by h. This is the derivative. For any function, if you want to find the derivative at a point a, you can denote this by f dash of a, and that value is nothing but f of a plus h minus f of a by h. That is very logical. The change in the value of function, that is f of a minus f of a plus h, is this, minus f of a. There is a change in the value of this function output by change in the value, change in the input. The input changed by h only, that is h. And since h is very close to 0, this is the concept of. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.